Well, hi, good morning. Thanks for joining me in my shop. So, yesterday I did enough to discover that the shortwave bands are working. They're receiving. So, with that in mind, I don't think I'm going to continue with the alignment of them. Instead, I'm going to remove a couple of more old capacitors. So there's four of them in here that got me a little bit concerned. There's these three molded ones here. You know, this one here in particular may be a problem maker. This is the tone capacitor. I don't think it can really make a problem as such. I'm not sure what this one's doing right now. Seems to be involved in the audio circuits because it's attached to this powerfully shielded copper tube here. So that's probably what that is. But the one that's really kind of got me is way down in the bottom of the chassis, down in there. And I'll give you a little bit of a closer look at it. The first three molded ones are simple. The tough one is that one back in there. What makes it particularly tough, and I gotta come up with a plan on how to do this, so I don't end up getting into a lot of unnecessary heartache, basically. So there's the capacitor. Its lead comes up kind of under the switch here. Let's see if I can get this to work. Comes up past the switch, the wafer switch, and connects right up here. So it's quite a long lead to get all the way down to the body of the capacitor, which is down here. So this was a tough one when they built this radio, how to locate this capacitor. The other lead from the bottom of the capacitor, and you can't see it anyway. The lead bends up underneath the capacitor about halfway back and then solders to the chassis. So this capacitor is way too big to fit in the space available. With the replacement I put in will be more like, can you see one in here? You can't right now. Yeah, up here, more like this yellow one. No, you can't see it. There we are. So see the size of the yellow one, which is actually a similarly positioned capacitor. See, I remember looking at this before and deciding I'd leave that one in there, at least during the next stage of troubleshooting and testing, which was just to find out if the radio is working well, working at all on all bands, and it is. So that's the guy I'm going to go at first. So I think, let's see, I think it's probably best to solder it down to the chassis. I have other alternatives here. There's other places to solder to. Here, here, through here. Well, they've got it taken right down to the metal chassis. It's probably better I just maintain that. I mean, they had an opportunity to bring that capacitor up this way too, didn't they? So they've done it down here. You know, I'm always suspicious that there's very specific reasons why parts are where they are. Or another way of looking at it, move a part a distance, and you may get a surprise result. Something even the design engineers never knew because they never tried. So I think that's what I'll do. I'll solder the new capacitor to the chassis first, and then, you know, how big are these? Let me get one. Let's just see where we can fit it in here. Can I slide it down here? I think I can. Actually put it in like this, get the ground connection, bend it down into place. You have to fish this wire way up there. Wow, that's a little tricky. So to do that, I'd have to prepare the wire first, like put a shrink sleeve on it, feed it up where it needs to go roughly. Look, now I'm on my way to soldering it up here first. I'm worrying about the ground connection later, but no matter how I do this, there's a big problem. I gotta stick a, let's see, I can get the soldering iron in here, no problem, but up through here? Well, you know what I'll do? I'll leave the I'll leave the, as I usually do, I'll leave the wire lead rather, on this. I'll cut it down here and leave much of the wire that goes down to the chassis sticking out, and then I can solder to that fairly easily. And then that will also give me some movement in case I have to solder it. Kind of, to get at the soldering, I do it in the wrong spot and then push it into the right spot. And this lead has to be long enough now to make it all the way up. Yikes! Wow, there's not much excess on this. Let me take a close look at that situation. Okay, so if it's sitting there, well, the lead's long enough. As long as it sits right up, just about exactly where the original capacitor is, tucked right up against the wafer switch. So that being the case, I'm going to have a lot of clearance to the to hook up the ground in this way. So that's what I'm going to do. So I'm going to sleeve this, put the capacitor in, connect it to this top point. You know what else I could do? I could cut the lead on this capacitor a little long up here, and leave it sticking out a bit where I can get at it, rather than what? So there's lots of ways to solder. There's this whole wire right here. Anywhere on that wire will do. So so I can snip the capacitor right off and say goodbye to it. So I think I've talked about this before, but I used to work in a power company, electrical distribution power company. I was in the engineering department, so I never did any real work. But lots of guys outside, of course, linemen and stuff like that, doing the real work. And there was a term that the linemen had that I learned called a jackpot, and it was a safety issue. I don't think it's a common term. I think it was just something at the company I worked at. And a jackpot is a situation where you take an action, and after taking the action you are almost guaranteed to be hurt. So you sort of, but through your own actions, establish a dangerous situation unexpectedly, of course, naively, from like a junior employee or something like that. If you do that, you know what's going to happen next, that kind of thing. And so they use this term a lot. So, well, we can't do that, that'll get us in a jackpot. And you can kind of generalize that term. It doesn't have to be related to safety. The jackpot, just getting yourself into a situation you really don't want to be in. A little hooky tool. Where's my hooky tools here? Let's see if I can do it with this. And that's what I'm worried about with this job. Okay, not safety. Just taking an approach that in the end leads to a problem. A bad problem. Okay, I think I can get the cutters in there now. It's hard to get the camera, the light, the cutters, and my eyeballs all in the same thing at once here. Okay, cut something. Often is the case, once you get the cutters in place, you can't see anymore what it is you actually are hooked up to. So I got the capacitor cut free up there. Now get them down here. Okay. Can't do anything with that hook. You can just see the wire I'm going to cut in the camera there. There he is. He's coming out. He's coming out. And he is a 0.05 200 volt, made in Canada, Canadian Marconi. This capacitor, this looks pretty good, you know. This doesn't look like wax. This looks like some kind of Yeah, that's not wax. That's a hard material of some sort. Very good shape. We're going to test this guy and see what he shows up, because I think he's going to show up good. It's kind of unfortunate. 0.05 did I say? 0.05. And the capacitor I dragged out is a 0.05 also. Okay, so this is the guy. Sleeve here. Where'd it come from again? Oh yeah, there. Okay, so I'll make a little hook here. Let's see if we can hook it on the right wire. Oh, it's got to. So close, but yet so far. Okay, I gotta change the bend on this. There, try that. I'm gonna hold this with a pair of pliers too, I think. Yeah, it didn't work. I just don't have enough. Don't have enough what? Don't have enough words. Okay, right up there now. There we go. Hooked on perfect. And unhooked perfectly. What happened there? I ruined my hook. Let's try that again. Didn't want that to happen. There we go. Hooked. Good. So I'm going to solder that top spot, because for sure it'll fall off if I keep fiddling around, and I'll end up nowhere. Ooh. Okay. Sometimes things happen in my shop off camera and you'll hear me, woo. You wonder, what was that? Well, you keep wondering. Just not everything is on camera, of course. The flip side of that is, while I'm working in here, I have to keep my eyes focused on my hands. I've explained this before. I've become aware that this is what we do. We keep our eyes on our fingers all the time, keep track of what we're doing. And so there can be things occurring just out of view of where I'm looking, just off to the side, and I cannot put my eyes there. I will not, because I'm working away at the soldering iron. Meanwhile, you're watching the video, and I know this from my own experience, and you can lazily look around all over the place. Often, people like you watching my videos can see stuff that I'm missing, simply because I'm not looking at it. I can't, because I'm busy operating my fingers. Okay, here we go. first time I saw this capacitor, I sort of decided, wow, that's one I'll never make an attempt at. But here I am doing it. I don't know. I don't think that's very good. Oh. 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 Whoa, I almost broke rule number 5 here of shop work, which is never do something with a soldering iron casually in your hand. You know how if you have a tool in your hand and you decide you need to pick something up, you can kind of manipulate the tool out of the way from your fingers briefly, pick something up, keep the tool in your hand. Never, it's tempting to do that with a soldering iron. Never ever do that. Always put the soldering iron away out of your hand. He says, telling himself. I'm not telling you so much as I'm telling me. There, I think that's a little better. Very hard to see in there. It's definitely soldered. Okay, now we're going down, going down to Lester's farm. Let's see. Wow. Okay, what to do? Should I cut that lead shorter? Cut it somewhat shorter. Trying to grab both of them at the same time here. There we go. Very carefully. There's some very, very fragile wires just moments away from where I'm doing this. I'm applying a fair bit of power on the pliers, so if I snag one of those light wires, I'll just rip it right off and never even know it. There we go. I think that's pretty good. Get in there with the soldering iron now. A funny shape in these panels here. This angular shape. I guess it's maybe clear that hole down there in the, you can't quite see in the camera. Or can you? Can you see it? There's a hole down there. That must be what they're trying to clear. Strange though. You don't usually see things bent in funny angles like that. Okay, let's get in there and throw some solder on that situation. There's another rule I try not to break, which I just broke, which is every time I finish with the solder, I kind of neaten it up. I wrap it back around the spool and I don't leave it laying out there. Just little rules I try to follow. How are we going to get up in here? Up this way? Can't get down through there. It's got to be up this way. So we're going to push that aside, push this aside, open up a big highway there. This isn't very good on the camera. Not much I can do about that. The other thing I find with doing this tight work is sometimes you can only get one eyeball on it. And with one eye, you can't really see stereo. You can't see stereo. And wow, does that ever make things a lot more difficult? The other thing is putting your work on a turntable sometimes doesn't work to your advantage. I can't tell what I'm doing here. Am I getting anything on this wire? One of them's got some solder. No, I can't see it. I don't know. I don't know if I got that. Yeah, looks okay. Now the capacitor position, it's right on this shaft here, so I'm just going to pull it. Pull it off the shaft. I did that. I did it. My poor gosh, I've done it. Okay, so I need to do these three. I'll do these off camera, these three here, because they're just so straightforward. Get them done quick. Then we'll try the radio out. There's the first one going in. One done. This guy next. Well, okay, so I started on the next capacitor here and started thinking about this resistor that's right here, and looked on the circuit, and what I believe this is the blocking capacitor going to the grid, the output tube. So that's a really important capacitor, and this is like a grid leak resistor, if you like. Not that this is grid leak biasing, but this guy is supposed to be 500,000 ohms. Let's check him out. I think I may have done this already in the past, but let's do it again. Check him out and see what he's worth. Because if I'm going to change it, now's the time. It's supposed to be 500,000. Just as I'm getting there. $600,000. It's really not a problem. Oops, that was almost a problem. 500,000, 600,000 in a situation like that doesn't really matter. What matters is this capacitor. So we'll leave the resistor, change out this capacitor. Is it a 0.02 by some chance? 0.01. 0.01. 0.01. It says 0.02 on the schematic. But of course, this is a radio that is some hybrid thing here. 0.02, 0.01. Let's think about this for a second. Now the output of this radio is a little low. This is the feeding the audio signal to the tube through here. This is really weak. It's going to quiet the radio. Maybe a brand new 0.01 would be fine. But hey, let's go for a double. let's follow what it shows on the schematic. We'll put a 0.02 in there. 0.02. As usual, I've forgotten where I cut this away from. Where did I cut this away from? Stuck way back in there. Okay, way back in there. Let's get a little. Where'd it go? The capacitor made a run for it. Oh, here it is, right here. Hiding in plain sight. 0.02. Wow, it's a little tough to get up in there. Let's shorten this. Shorten this. One side of this capacitor will be basically a ground potential. Basically, the side on the grid, this side. The other side, this side here, the one that's hooked up to the wire, it's got B+ on it. That's dangerous. Floating around like that. Well, it's going to be floating when I'm done too. These wires here are very, very stiff and can't be bent. I can see the cracks in the insulation while I'm doing this. Oh, jeez. Very close. Okay, that can be soldered. When I was working for the power company, I received a fair bit of safety training. And there's one particular thing we were taught. It was like a 3-day course in something called loss control. And I learned more about how to do things in that training. So why am I bringing it up? There's a whole theory around the way to run a business is not to try to control profit, but the object is to control loss. If you focus on loss and controlling losses, the profit will take care of itself. That's the theory. I worked in a public utility, so profit and loss wasn't really an issue. But staying on budget and all that kind of stuff was certainly a big issue. Okay, hang on. Get rid of all this. You kind of think of loss control all the time in your life. What kind of losses are you talking about? Just about everything you can think of. Anything you can define as a loss is worth bringing into this theory of loss control management. I believe it was a guy named Bird who worked up these ideas. And they're not. It's extremely practical training. It's not just here's a theory, now go back to your jobs. It was very, very practical. We adopted much of it at the company I worked at. It was really a change in attitude, or a not so much a change, but like an increase in your attitude, if you like. Okay, let's get the soldering iron going. An increase in your attitude. That's what I have. I have an increasing attitude. So I don't know how many people, how many other companies approached safety as a loss control issue, a straightforward business issue. Somewhere I have a book. Somewhere I have the manual here on loss control. Okay, did we really get that soldered right? She's there. I did say something about not videoing these capacitor changes, didn't I? I'm going to do these off camera. Yeah. Okay, another one test. That's 3 capacitors, 1 more to go. That guy there. Now, I can certainly see this lead and where it's connected. I can't see the other lead. Where's the other lead? So maybe I'll unhook this one first. Try and remember where it came from. That's easy. Yeah, I can see. Pull it out and see exactly where it's from. I'm going to cut that back there. Put away your soldering iron, Jim. You gave a speech on that. This one feels a little different. There's a sealed tight wax molded capacitor. That pretty much lays it out. 0.006. It's a little teeny guy. 0.006. Okay, these are a little bit mixed up here. I'm pretty sure that's a 0.006. Try just to double check. So 0.06 would be 60 nanofarads. How about 6 nanofarads? Wait a minute, maybe I got that. Maybe I do have it wrong. No, this is a 0.006. So 0.006 is 6 nanofarads. There you are, 6.8. It's got a little extra. Comes with an extra 0.8. No extra charge. And where's this go again? Okay, right in here. I'm just trying to scrape this wire a little bit. It's not working so good with my pliers. Okay. I still got the camera running. Oh, there's way too much wire here. Solder that. Don't fall off now. They're interesting little terminals they've got here to make it easy to hook wires up. Can't say I've ever quite seen these forked three forks coming up and you stick the wire like that. Maybe you pinch this a little bit afterwards and then solder. It's pretty good. Pinch the connector a bit. Lay it on some solder. Yeah, talking about injuries and hurts that happen in shops. I've got a classic bobo on my finger here that happened off camera yesterday or the day before. A classic. I'll show you my bobo. You know how I got that on my finger? It was, I will demonstrate. I will demonstrate without doing it. I was trying to tighten a nut like this one here. The only thing I could do it with was with these. So I'm out here like this, and I know better. I know it's gonna slip off. It's gonna slip off. Oh, that's that loose? Did I just turn that? No, I'm imagining it. And somehow I had my other finger close, and it slipped off. Snap! Just crushed that little bit of my finger there. I'm showing you that because if you do this kind of work, you know exactly what I'm talking about, because you've done it too. Shame on all of us. So, did I solder that at the back? I don't think I soldered it at the back there. Let me solder it, and we'll know for sure. Yeah, I think I almost forgot this connection. I don't know. Who knows? I don't know. I don't remember. That was all a 4 minutes ago. How am I supposed to keep track of all that? There we go. Okay, so this radio is ready. Ready for a test out. Okay, I'm going to leave it tipped up the way it is. Antenna is a piece of wire. Just a piece of wire thrown on the floor at this point. Okay, 1 second here. And we're ready. I think we're ready. Yep. Let's put this here. And fire on. Fire on, radio. Volume is... Ooh, volume was right up. Volume down, because it could be quite different this time. Lights on. Dim lights behaving normal. In fact, that wasn't normal. Wow. Okay, so, wow, something seems to be a lot different. So I think those lights used to come on a lot brighter. It's not necessarily a good sign. Because they went right down to nothing and back up to where they are now. 94 volts being supplied. Only 30 watts. That's not very much. Usually these things are kicking up around 80, but it is a restricted. It is a, turn it up, see what's going on. Why is there nothing? How did I boob it up? Did I boob it up? How could I boob it up? Talking too much? Okay, so we're going to turn it up. That's up. It's probably on a short wave band. Turn it down. There you are. There's the AM band. Wow, talk about volume now. And my hand's rotating on the shaft a bit. I'm hardly moving it. Okay, so let's go around where 640 here. Okay, I'm going to hook up the other end of that antenna. Okay, we're hooked up outside now. Something there right now. Let's go full voltage here. It's just a lot of interfering noise, and the long wire antenna doesn't help much. It's definitely working. Let's go on the shortwave band here. Okay, so we're on shortwave 2. And we're at the low end. At this time of day, we might get something up in this area. Let's see. Why so quiet? Oh, just disappeared. That's full volume. There's a lot of strange things in that sound. Wow, this really got some problems there. Let's keep going. Okay, we're just up full. Oh, I didn't try the tone control. Wow, it's pretty darn weak up here. Probably can't spot that station again. So a little insensitive. Antenna's not the best. Let's go down, down, down. Back to AM. Let's see what's possible. What's possible? Let's put a station. I don't even need a station. Just to test the tone control. It's all right at the end. So I don't know why that is. It was better before. You got me why it's like that. Makes me think the capacitor's not at all the right size. And it just goes from shrill to totally muffled. Just in the last few degrees of that control. So the tone control is worse off than it was. Okay. So now we'll go back to the alignment process on the two short wave bands. See if we can't pick them up. That could be all it is. Just alignment now. So poor on this radio. It's just got no oomph. Obviously the audio portion's got some oomph because the AM part of the radio is feeding a good solid signal to the audio, and it's coming out of the speaker loud, so that's good. Not bad. Probably maybe 1 or 2 more sessions and this radio is done. Great, because I've got a couple of tubes on the way in the mail coming for the Nordmendi radio, so I'll be ready to work on that again in just a couple days. Hey, fantastic. See you later.